Hi all, this is E. Manjula, lecturer in Electrical and Electronic Engineering, Government Institute of Electronics. So today we are going to deal with the problems on Kirchhoff laws. So in the last session, we have seen about Kirchhoff laws, that is the current law and voltage law. So once we will revise the Kirchhoff current law and voltage law. So we know that the current law says that the algebraic sum of all the currents entering and leaving a node must be equal to 0. And this idea is by conservation of charge. And the voltage law so we know that the voltage law is that the algebraic sum of all voltages within the loop must be equal to 0. And the voltage law idea is as the conservation of energy. So now we will see the problems on KCL and KVL. Okay, fine. This is the problem. First we will see the problem. The two batteries A and B are connected in parallel and a load of 10 ohms is connected across their terminal as shown in figure. The battery A has an EMF of 12 volts and internal resistance of 2 ohms, and the battery B has an EMF of 8 volts and an internal resistance of 1 ohm. Using Kirchhoff laws, determine the values and the directions of the currents flowing in each of the batteries and in the external resistance. Also, determine the potential difference across the external resistance. So this is the problem. So here the diagram is. So here the diagram is. This is a 12 volts battery and this is an 8 volts battery. A is a 12 volts battery and B is an 8 volts battery. Has a 2 ohms resistance, internal resistance, and 1 ohm internal resistance, and this is an external resistance 10 ohms. And here now first we have to select the loops. Okay, so this will be the first loop in this direction. Okay, fine. First I will take one pen. Okay, so this will be the direction of loop. So that means A, D, B, C, A. Okay, let X and Y be the currents here. This is assumption direction, we don't know. Anyhow, it has been already given in the question only. So as because the battery is in battery, the direction of the current is taken from the battery. Okay, So the battery here it is positive, so the direction of the current will be like this only. Okay, fine. So let X and Y be the currents in batteries A and B respectively. Applying KVL to mesh A, D, B, C, A. That is, see here. So this is a loop. Sorry. Okay. So this is a loop. And see the current direction is here. The current direction is opposite to the loop. And this is a battery. See the battery is going from the negative, or this from negative it is going, and opposite direction. Okay, so here this is minus 12 volts plus 2x minus y, then plus 8. Okay, minus y means minus 1 into y, because it is 1. Okay, so minus 12 plus 2x minus y plus 8 is equals to 0. So the thing you have to remember, this signs. The signs are very much important. How you are getting the sign, positive and negative and all. Okay. So remember that here we are going from, you at least consider from this end or else this end. Okay. So consider from the last end. Here it is minus. So you kept it as a minus 12. And the direction of the loop and the current directions are opposite, so you will put plus 2x. And here if you observe, the direction of the current and loop both are same. Here both are same, so hence it is minus 1y. Then the leaving end of the battery is positive, so it is plus 8, which is equals to 0. Okay, this is the way you can remember. And yes, so from this you can write that it is 2x minus y is equals to 4 as equation 1. And now we have to take another mesh. Okay, so here I'm considering the CBDEC. Okay, so CBDEC. Okay, like this one do, CBDEC. Okay, so if this is a loop, now here, so this is minus 8, and the direction of the current and loop were opposite, so plus 1y. And if you see the direction of the current and the direction of the loop are opposite, so plus into x plus, sorry, 10 into x plus y, which is equals to 0. So here, so 10x plus 11y is equals to 8. This is an equation 2. So resolve this equation to a simple manner. So you'll get like this. Okay, 10x plus 11y is equals to 8. This is an equation 2. Now multiply equation 1 by 11. Then add equation 1 and 2. Okay. So here multiply this equation by 11. So 11, you will get 11. This will become, after multiplying, 22x minus 11y is equals to 44. Okay. So for this equation, you are adding 10x plus 11y is equals to 8. So this 11x, 11y and this 11y will get cancelled. Okay. So 22x plus 10x is equals to 44 plus 8. That will be the equation. So then that is 32x is equals to 52. Okay. So now x value is equals to, it is 1.625. But we know x. What is x? X is a current. Okay. Which is coming out from that 12 volts battery. Okay. That direction, if we go back, see here. So this is a current. Okay. So hence it is amps. Okay. So the x current value is 1.625 amps. Now substitute this x value in any one of the equation, either equation 1 or else equation 2. Okay. So here it is substituting x value in equation 1. Then you will get y is equals to minus 0.75 amps. So what does it mean? The direction of y is in reverse. Okay. Because it is minus. So from this we got uh, the currents x and y. Okay. Okay. Now we will go to the second example. Seems to be complicated. When we see the network, you will feel it might be a complicated, but when you solve it, it will be very interesting. Okay. So find the currents in each branch of the circuit given. So this is the circuit given. I will try to take some point. So this is the circuit given. So we have to solve. We have to take the loops. So this will be the first loop. What? A, B, G, H, A. Okay. Loop 2, loop 3, loop 4. Okay, like that. So first applying KVL to the mesh A, B, G, H, A. Okay. That is, see, you should always remember the direction of the loop. So this is the loop. Okay. So the direction of the loop and the direction of the current is in same direction here. So it is minus 2x. And the direction of the loop and the direction of the current is same here. This is z. So minus 2z. And the direction of the loop and the direction of the current is same. So it is minus 2x. And what is the leaving the terminal? That is positive. Okay. What is the leaving terminal of the loop? It is a positive. So it is plus 10, which is equals to 0. Okay. So you will get, solving this equation, you will get 2x plus z is equals to 5. This is equation 1. Then applying a KVL to B, C, F, G, B. Okay. Now 2x minus z into minus 2x plus y plus z minus 2x minus z plus 2z is equals to 0. Okay, so this is only 2, this is not there. Okay, so 2 minus 2 into x minus z minus 2 into x plus y plus z minus 2 into x minus z plus 2z is equals to 0. So see here for KVL and KCL, the very important is signs. How you'll put signs, you should remember it. Okay. Now by solving this equation, you will get 3x plus y minus 4z is equals to 0. Okay. So applying KVL to mesh C, D, E, F, C. So here minus 2y minus 4, sorry, because the direction of this and this both are in opposite direction, so plus 2y minus 4, then minus 2 into y, then plus 2 into x plus y plus z. Then totally after solving this, you will get x plus 3y minus z is equals to 2. Fine, we will see the solving of this. For at least one we will try. You could able to understand all other solvings which is kept directly here. Okay, so once we will try this. So here 2y plus 2y 4y and plus 2y 6y I can write. Okay, okay, then here directly I can write 2x. 2x plus 6y, then 2z. So this is also plus sign, which equal to 4 I'm taking to the right hand side. Okay. Now I will take 2 common in this, or else take 2 common here and 2 and 2 in this, and all 2's will get cancelled. So that is how you will get x plus 3y. Once again. So here this is x plus y plus plus minus z. So here this is x plus y minus z, ma, because see in this branch it is x minus z. So here this is y. So it is x plus y minus z. So this will be minus z. Okay. So here this will be minus 2z. Sorry. So this will be minus 2z. Okay. So 2 will get cancelled, and you will get the equation, that is the third equation, is equals to x plus 3y minus z is equals to 2. Okay. By solving equation 1 and 2, what we got equation 1 as solving both the equations 1 and 2. Then you will get 30x is equals to 50 and x is equals to 50 by 30, which is equals to 1.833 amps. And substituting the value of x in equation 1, you will get z is equals to 5 minus 1.833 is equals to 1.333 amps. So Z is equals to 1.333 amps. Then substitute x and z values in equation 2. Both x and z if you substitute, then you will get y. Then y is equals to 5.33 minus 5.499 is equals to minus 0.1657 amps. So if you want to redo the equation solving, that is also better. So substitute solving the equation 1 and 2. Okay. So here we have equation 1 and we have equation 2. Once we will solve here only. So here we know that 2x. So here directly I can put it to 4 into 4. Okay. Whole part. Then what happens? This is 8x plus 4z is equals to 20. Then this and this will get cancelled. Okay. At that time you will get 4 into 8x 8x plus 3x, no? 8, 9, 11x. Okay. Plus y is equals to 20. This is an equation having the parameters x and y. Okay. And here we have x plus 3y minus z is equals to 2. Okay, from here also you can get x and y parameters only, including x and y. So you take equation 1, first equation, that that equation is 2x plus z is equals to y. Okay, so here if you take 2x plus z is equals to 5. So this set and this set will cancel and you will get here 3x plus 3y is equals to 7. So now you got two equations. Okay, this you can put as 3, no, 4 and 5. Okay, so the two equations you got of x and y parameters only, which you have only x and y parameters. Okay, see here, this is 11x plus y is equals to 20, and here 3x plus 3y is equals to 7. So by solving these two, anyhow we will solve that also though, so that will be very much clear about it. Okay, so 3x plus 3y is equals to 7. Okay, and what is the equation 11x plus y is equals to 5? So 11x plus y is equals to 20. Okay, put this down above. Okay, now what you do is multiply this into 3 total part. Then what you'll get is 33x plus 3y is equals to 60. Okay, then put here the equation 5. So what you do is you subtract the value. So minus here, minus and minus, you will get 30x is equals to 53. Okay, so you will get x value. That is how in here you got 50. Here is coming 30x is equals to 53 only one. Probably this is typing mistake. Okay, so you'll get some x value. And now substitute the value of x in equation 1. You have got an equation 1 that is 2x plus z is equals to 5. In that, if you substitute, you will get directly z value. Okay, then substitute x and z values in equation 2. You will get the y value. So this is how the way you have to solve it, because I have shown the point each and everything so that you could able to understand step by step. Okay, now we will go for the another problem, that is three batteries are there that P, Q and R consisting of 50, 55 and 60 cells respectively and are connected in series. Supply a common load of 1100 amps and each cell has EMF of 2 volts and internal resistance of 0.005 ohms. Now, determine the current supplied by each battery and the load voltage as shown in figure. Yes, so this is the figure. So here this is a P battery, Q and R. Okay, having 50 cells, 55 cells, 60 cells. 50 into 2 because each cell having 2 volts. So 50 into 200, 55 into 2 110 volts, and 60 into 2 120 volts. So this is a total voltage. Okay, and each one has an internal resistance of 0.005 ohms. Okay, so 0.005 into 50, 0.25, 0.005 into 55, 0.275, 0.005 into 60, zero point 0.3 ohms. Okay, so these are the internal resistance. And here this is a 1100 amps load. Okay, and this is a load. Now the given data is Vp, Vq, Vr, and I1, I2, I3 combinedly, which is equals to 1100 amps, and Rp and Rq and Rr. These are the internal resistance. Now we have to find I1, I2, I3 and V load. Okay. So here let I1, I2, I3 be the currents in P, Q, R branches respectively. So this is I1, I2 and I3. So applying KVL to mesh A, B, C, F, A, you will get 100 plus 0 point minus 100 ma, because this is only the leaving point. Okay, minus 100 plus 0.25 I1 minus, see both are in now same direction, it will be the current direction. Okay, minus 0.275 I2 plus 110 is equals to 0. Okay, so from this equation now it is 0.25 I1 minus 0.275 I2 is equals to minus 10. This is an equation 1. And next loop, that is F C D E F. So here minus 110 plus 0.275 into I2, then minus I3 into minus 0.3 into I3 plus 120 is equals to 0. So from this equation we will get 0.275 I2 minus 0.3 I3, which is equals to minus 10. This is an equation 2. Now applying KVL to the mesh F, F, E, D, C, H, G, F. Okay, so this is a loop like this. So from this it is minus 120 plus 0.3 I3 and plus 1100 R is equals to 0. So now we got three equations, and also we know that I1 plus I2 plus I3 is equals to 1100, which is a fourth equation. So from fourth equation directly we can write I3 is equals to 1100 minus I1 plus I2. Then substituting the value of I3 in equation 2. Okay, so substitute the value of I3 in equation 2. Then you will get, substitute it and solve it, resolve it. Okay, we'll get 0.3 I1 plus 0.575 I2 is equals to 320. Okay, then solving equation 5 and 1, first equation, then you will get 0 minus 0.22625 I2 is equals to minus 83. Then I2 is equals to 366.85. So now we got equation, we got I2 current. Okay, now you can directly substitute this I2 in any one of the equation, like here in equation 5 you can substitute. Okay, then you will get I1 directly. Or here, substituting the value of I2 in equation 1, you will get I1 is equals to 3.536 amps. So you can substitute I2 value in any one of the equation where you will get only single parameter. You have to check when if there is a two parameters, say I1 I2 or else I3 I2, you have already got I2 parameter, so you can substitute in any two consisting parameters so that you will get other unknown parameter directly. So here we got I1 is equals to so and so. So we know I2 and now I1. So directly you can substitute I2 and I1 in equation 4. Then you will get I3 is equals to 369.614. And yes, we know that I1 plus I2 plus I3 is equals to 110 amps. So make sure that you may get doubt that whether did I get a correct answer or else not. Okay. So substitute I1 plus I2 plus I3 is equals to 110 amps, that we have fourth equation. In that fourth equation, it should tally after substituting all the values. Okay. Now substituting the I3. So we know I3 now. So substitute the I3 value in equation 3. You will get R. Okay. So the load resistance is 0.008287 ohms. So we have to get the load voltage. So load voltage we want, so we have to find out I into R. I is nothing but here total current I1 plus I2 plus I3 into R. So we know now R and we know the total current. So we can directly substitute the values in I into R. Then we will get the voltage across the load. The load voltage is 9.1158 volts. Yes. Okay. So we got all the values. Okay. So now we got the load voltage also. Now next we will go to the another problem. Okay. So here this is a problem figure. Now determine the current X in the 4x resistor here. Okay. 4x resistor of the circuit as shown in figure. So this is a figure. So this is a current X current. We have to find out what is this current flowing in this. Okay. So you will get one direction like this, one current direction like this, another current direction like this. Okay. Now applying KVL to the mesh AC. One second, I will write that there is a AC value separate. Okay. Okay. A C K H A. From this I can say this is everything like this. This is X. So this will be Y, and this is Z. So here, don't get confused, it is very clumsy. I'm not getting eraser actually. Okay, fine. See here, I will explain you clearly. Here this cursor is this. Okay. Here what happening? This is x, the x direction. Okay, and as this is a voltage source and this is one of the direction, that is y. So y is passing like this and x is going like this, so x will be going like this till here. Okay, and y is still here, and this is y minus z, and the z is going into the down direction. Okay, so this is y minus z, and here at this junction we are adding plus 6. So here from here it will be y minus z plus 6. So y minus z plus 6 is flowing like this. Okay, when these two it will come at this point, this is x plus y minus z, because 6 will go like this. Okay, and at this point this is x plus y. Okay, and this is x and this is y. So this is the direction of the currents. Now we will see the loop. So this is the first loop, this is the first loop. Okay, here this is in this loop, the direction of the current and the direction of the loop is same, so it is minus 10z plus 1 into x plus y in minus z. Okay, plus 2 into y minus z plus 6 is equals to 0. Okay, from this equation we got x plus 3y minus 13z is equals to minus 12. Okay, and apply KVL to CDEKC. Okay, that is the second loop, this loop. Okay, here this is plus 2y minus 10 plus 3 into x plus y and plus 10z is equals to 0. Okay, so this is the second loop. So we got two equations here, that this is 3x plus 5y plus 10z is equals to 0. We got two equations with three unknown parameters. Okay, so there is one more loop, this loop. Okay, in this loop both are in same direction, so this is passing x plus y minus z. Okay, so 1 minus x plus y minus z minus x plus y, x plus y. Okay, and this is x plus y minus z. Okay, and minus 4x plus 24 is equals to 0. So minus 8x plus 4y minus 4y plus z is equals to minus 24. So this is equation 3. So now we got three equations. Okay, so from these three equations, the three equations have three unknown parameters. So by multiplying equation 1 by 5 and equation 2 by 3, okay, we will get 5x plus 15y minus 65z is equals to minus 60, and 9x plus 15y plus 3z 30z is equals to 30. So equation 1 and equation 2 is going to change like this, and from subtracting 2 from 1 we will get minus 4x minus 95z is equals to minus 90. Okay, now multiplying the equation 2 by 4 and equation 3 by 5, we will get 12x plus 20y plus 40z is equals to 40, and 40x plus 20y minus 5z is equals to 120. Now subtract. Then we will get minus 28x plus 45z is equals to minus 80. Okay, now multiply equation 4 by 45 and equation 5 by 95. Then you will get minus 2840 x is equals to minus 11650. Then you will get x value is equals to 4.102 amps. So our target is to get only x value. They have not mentioned about the y value or else z value. They have asked us to find out the x value. So our target is x value. In such that way we have to solve the each and every equation to get first x value. Okay, so we got the x value. We can meanwhile we can find the y and z value also. Okay, by substituting the x value in the previous equations. So this is how we have to calculate the to get an unknown factors from kvl and kcl method, using kvl and kcl method. It is very much interesting. Once you go on solving each and every problem, then you will get interest in it. So in this summary, we have solved the problems on DC circuits by using Kirchhoff laws. Okay. Hope you understood the total session. Uh, we have applied the KVL and KCL in the problems for finding out an unknown values, unknown current values, and unknown voltage values. So these are the problems which are these are the I mean KVL and KCL laws will be used for DC circuits. Hope you understood the application of KVL and KCL. Thank you so much.